Okay, James pushes a box with a mass of 45 kilograms along the floor. So let's draw a picture of that. Here's the floor. Here's James pushing the box. And he's exerting 258 newtons to the right on the box. Right? So let's just draw a little picture of that. There's our arrow. And it's accelerating in that direction to the right at 2.1 meters per second squared. So what must be the coefficient between the box and the floor, right? Okay, 45 kilograms. Well, I think we're going to do this in 2 steps. The first step is we're going to figure out what this force of friction is. I bet there's a force of friction acting that way, right? So let's set this up. We're going to use F equals ma to figure that out, right? Okay, so let's see. The sum of the forces are 258 minus, or I'm going to say plus F. We'll let the F become negative if it wants. And that equals 45 times 2.1. Okay, so let's solve this. I think what's going to be is we're going to go 45 times 2.1 minus 258, right? Negative 163. Right, so that's what this force is, and of course it's to the left. Friction would oppose the direction you're sliding, right? So now we're going to use the idea of the force of friction, right? The force of friction is mu times the normal force, right? So that means the force of friction is mu times m times g, right? So let's just toss this number in there. I'm going to make it positive because I don't want to get a negative coefficient, right? 163.5 equals mu times 45 times 9.81. Some people were asking me why do we make it positive over here? I don't know. But I just don't want to, there's no such thing as a negative coefficient of friction. So this formula is in the sense of everything being positive. Okay, so let's see, let's divide that by 45 divided by 9.81. And I've got 0.37, oh, that's cool. 0.0370 bar. U is 0.370 bar. That is wild. Okay, so with 2 sig figs, I guess we'd have to say 0.37. There are no units.